Hi, it's Gadget UK here again. Thanks to Kavanoz for this board. In the previous video we couldn't get the SCSI working, and we still can't get the SCSI working. You'll see we're picking up here, just doing some experimentation with the cable and stuff. Yeah, let's see if it's about insane termination. So I've got this huge SCSI cable here, multiple devices out of the server or something, isn't it? Amphenol. This sounds like a medical thing. Anyway, let's try this. Let's try this crazy length SCSI cable. I have this SCSI to SD in the front room. So pin 1 is towards the power connector. Let's get the SCSI card down near the thing here. There we go, with this pin 1 that way. Let's stick the terminator that came from Kavanoz here on the very end. So it's got active termination. It's got a mile long SCSI cable, but nevertheless it'll be interesting to see what happens. Switch it on. So at least it's terminated fairly close to it. But you see, I think the SCSI to SD is configured to have termination. It's one of the options. You can configure it so that it terminates itself. It's not doing anything, is it? It's doing exactly the same thing, just light always on, but nobody home. If it was going to work with either cable, it would be the short ones, to be honest. Long cables and SCSI aren't best friends. So I think we can say we've ruled out termination, probably. We don't have the resistors fitted on the board here, but someone was saying you don't need them. Unless you're trying to, I don't know, why do you need them? Why would they be on there? If you had them there, you can't use the external port. But then, does that not mean you've got to have a terminator at the port? So maybe we should have them on the board. May as well remove that RAM from the back now, because you know what, it's serving no purpose at 1 meg. It's just going to make it a bit more fiddly when we come to do the zip. And a valuable test for my sanity here, booting this without a SCSI chip. Yeah, it black screens, as you can see there. So I'm going to confirm with the guys on Mike in his Discord for the Re-SDMAC. Is that a case, if the SCSI chip's missing, will it just give you a black screen? Is this a Kickstart 3.2 specific behaviour, or is it a Re-SDMAC behaviour, or is it a case of no matter what Kickstart you got, no matter what DMAC you've got, this is normal? Because, well, it's useful information, really. It shows that the initialisation on the DMAC side of things, if the chip is not there, the system just doesn't do anything, which is interesting. I didn't expect that. So anyway, I'll get that chip back in, which comes from my A590, one of them. Yeah, there we go. No SCSI chip or a faulty SCSI chip, you'll just get a black screen. And that's interesting because you only get that behaviour with Kickstart. If I was to test with Diagram, it would be fine, it would work fine. Because Diagram disables interrupts, doesn't care about the auto config, doesn't care about SDMAC. It just presents a menu, that's not interrupted by anything. And you can test feature. Kickstart is a different beast. In the same way, the tick will cause you a problem. You can have the tick not there at all, and Diagram will work fine. As soon as you come to boot Kickstart, the tick is a big problem. If you don't have a tick signal, that specific interrupt on CAA, the signal's not there, the system just black screens or gives you weird behaviour. Anyway, I'm very pleased with that. I'm just wondering, this is purple. I think that means you've got a boot device. Yeah, I think if I was to disconnect the floppy drive, let me just do that. Yeah, there we go. Red background. So, yeah, that's actually useful. I like that feature of Kickstart 3.2. I mean, this is the thing I point a lot of hate towards Kickstart 3.2 and 3.1.4. But, they did fix lots of things and bring lots of new features in. And yeah, I'm going to roll with 3.2 on this board, I think, ultimately. Right, so here we are over a week later. I've got some more WD ones here. WD3C93APL, Mark Proto. Probably fakes again. And I got another one here from Eastring, who's usually very good. I think it was. It might have been from someone else, actually. And this one's an AM one. If you believe it, it's marked AM33C93. So let's try this one first. If any of them are going to work, I would expect this one if it's genuine. And I think you can identify it, can't you, using the test software we used to check the DMAC previously. That will, I think, ID it. And I don't think they can fake that. But what some of them are doing is selling the WD ones as AM chips. Hang on, that's marked Micro Hut. I'm confused now. Maybe I did order some other chips from somewhere as well. But anyway, this one's come from Micro Hut. And you know what? All the other ones have come from Micro Hut. And they've been the WD chips, not the AMD ones. But you can see that's painted, solder code pins. You know what, I don't hold high hopes for this. I'm going to try and hook it under the chip there if I can, and then lift it like that. There we go. Move the SCSI cable out of the way, hook it on this side and lift it. There we go. That socket's not the firmest socket in the world, but anyway, I know it's not the socket that's the problem. Pin 1 is down towards the bridge, you know, the daughter board here. Let's see what happens with that. I'm going to power it without anything connected and just feel the top of it. Make sure it doesn't go nuclear, because some of those chips do. There we go, that's booted. And the interesting thing is that came up really quick. It didn't do that before. Let's try it again. Look how quick that came up. I don't know if that's a good sign or not. Normally it took about 20 seconds or so to come up with that. Anyway, let's connect the Zulu SCSI Compact Homebrew here, and I'll just reseat the micro SD. Let's just try that. It is powered by its jumper. Let's see what happens with that now. It's on. Access light on just all the time. Yeah, I don't think that's made any difference whatsoever. It's just on all the time. Yeah, you can see that. Hang on, it's just gone off. And this is what it was doing before. So for me, somehow the Re-SDMAC is just not working with the different SCSI drives I try. Yep, that is doing exactly the same as before. So I don't think that's working. So we'll try one of these WD chips, but well, I don't hold high hopes with these, because I think a lot of these are just, let's say, faked, and they're the slowest, buggy versions, etc. Instead of the more desirable versions that you would want to install on anything Amiga related, really. And you can see the chip there. Right, let's power cycle that, because that's giving up booting again. Of course, there could be a problem with the Re-SDMAC. Like maybe, I was going to say a bridge, but you know what? I've double checked that I don't have any bridges anywhere by beep testing all the way around it. There's no bridges. I don't know. It's mysterious, this. Yeah, the legs are a bit gull wings, so let's just press it down onto the ESD marginally on both sides. I don't know why they seem to do that. It's like when they return the legs, they then go, right, let's go with it, so everyone thinks it's new. When clearly it isn't, so it's like, why bother? I don't know why they do that. I don't know why they do half the things they do to these chips, to be honest. And I can test it on the A2091 just to make sure it does actually work, but anyway, let's see what happens now. I won't flash off and on, hang on. Haha, it's not doing anything again. I don't know, I'm losing my mind. Yeah, testing with the AMD Mark chip. This is the thing. Should it actually say AMD there? The fact it says WD really is, you know, shows me that it is a WD chip, I think. Saying microcode 0D, 14.2 MHz, but then pass on these things here with no drive connected. If there's a drive connected, it just never boots. This is the problem. It's always when the drive's there, it will never boot. So I don't know what to do. I just don't know how to progress with this. Yeah, it doesn't even seem any different with that one. One thought I did have, I hope the firmware update on this didn't kill the Re-SDMAC. I mean, how would it? Because this is connected to the SCSI chip. But in any case, it's now behaving completely differently. We just get that one flash and that's it. Yeah, and this AMD chip here is as fake as you can get. You know, it's like the worst example of a fake, is what I mean. Because you can see here, can you see on the surface? You can't scratch paint on a chip like that. So, well, look at that. That is as fake as you can possibly get. I'm going to go and complain to the seller in a minute. This is not an AMD. It's being identified as a WD. And the layer of paint on there is just nuts. It's clearly been milled down. I don't think we get any chance of being able to see what it was. Do you know, I'm starting to get through to an actual scrubbed off part number. Well, what is interesting is it does have the AMD symbol. Is it a fake of a fake? In other words, it was originally faked and it wasn't an AMD chip. And then they've painted it, because I can see the AMD symbol there. I mean, I wouldn't use it like this. I'd pull that label off and clean it up entirely, I think, and then stick my own label on it if it turns out to be a genuine AMD one. But it's detected as a WD, but maybe that's the case with the AMD ones. Yeah, there's a really cool website that I'm just showing you briefly here. There'll be a link to it down below, but it covers all the different revisions of these SCSI chips. There's loads of different revisions, you know, A through F or something. The proto ones, there's different microcode on each one of them, and from different manufacturers, etc. It lists like the pros and cons. It's a bit of a guide to help you work out which ones are fake, etc. It's really useful. These chips are used on other systems as well, maybe some Macs or PC stuff, but primarily the Amiga. You get them in the A590, the A2091, maybe on the A2090, I'm not sure. And I do know we've seen them on some of the third-party cards as well. Right, I'm going to do the Intune mod to the CPU slot, because none of my CPU cards work really. Now that could be because of the Re-SDMAC that I'm currently testing with. Nevertheless, I figure let's just get this out of the way. So it's just looking at the diagram here. You know. Yeah, it's the 10th one down on the Zorro bridge, you know, the daughterboard thing here. 1, 2, 3, 10. It's like the pin 19 basically. And then I've got my Kavanoz here. Let's just turn the end of this. See what I'm doing. Right, I'm just going to trim that back because that's a wee bit long on the end. You can see what I'm doing again. That's it. And then I'm simply just going to heat that into that point there. Just check it's on. It is. I'm just going to inspect with magnification. That looks okay. And then I'm just going to carefully route it between pins here. And it wants to go right over here somewhere, so I'll just work out where. Do you know what? I think I'm just going to hot melt glue this down over here somewhere before I do anything else. Yeah, and then, yeah, all being well, I can just reach it over here, so I need to work out where it needs to go on there now. And it's like the second row here, and it's 1, 2, 3, 4, fifth one along. Yeah, and it kind of shows you that there are some common grounded pins here. Can you see that? There's a cluster of 3, cluster of 3. So it's the first one after that first block of 3. That first little clover leaf type arrangement. So, yeah, it should be dead straightforward, this. There we go. That's it, mod complete. Well, except for the bit more glue that I'm going to put on it. And I think I will reheat that blob there because it's kind of left aligned. And even that one maybe. Right, that's it. So it's tactically secured there with 3 blobs. There's nothing here for it to pierce on. And it's away from anything there. I'll just double check that. Yeah, it was still showing 0 megabytes of RAM. And then I realised one of the sims was not in right. There we go. And it was obviously the first one it checks. Yeah, so the RAM is okay again. Yeah, and at this point here, I decided to have a look at the firmware, and it was on 0.9, I think was the latest version. I reverted it to 0.8. That made no difference at all. I eventually put it back on 0.9. I then went back to looking at the actual pins around the adapter to make sure there were no bridges. Yeah, I just ultrasonicked this because I saw this flux here, and it was between those 2 pins as well. And there's no there's a resistance, but there's not a short. I'm just wondering if this is something to do with the problem on this, what I'm having with the SCSI here. It's driving me nuts. I've done so much, spent so long. I'm just going to heat this and just see what happens to that goo behind. It's really hard to do on the microscope. If we just heat that pin. Was that some solder? I don't know. Do we have a bridge here now? I would say this is one of, if not the hardest thing I've ever had to solder on my channel. There's a bridge there, isn't there? There is a bridge there. Let's just try and distribute some of this solder along here. Yeah, it's a little bit blobby. We're so close though, you cannot see that with the naked eye. That's the point I would make. I would think those are okay now. Whatever flux has gone, we'll just give it another try. So hours later, getting nowhere, I thought we'll use the A2091 here to test these crazy SCSI chips, of which I've now got 3 more, and we'll test the other 2 again, but I'm going to test them at 14 megahertz. So I switched it off. That's booted, just take my word for that. So it's worked. Hang on, let's get the strap on. It's worked at the 7 megahertz-ish clock speed that this is currently jumpered to, and from factory it's like a soldered thing here, and I put, let's say, 3 pin header there, but it's not a case of you just move the jumper over. You've got to pull the jumper off, and then you need to use a DuPont and go from the outsides of the 3 pins to each other. So like that is in 14 megahertz. Now my guess is with the chip that's in there now, it's the original one, it won't work. So yeah, that is really confusing because that seems to be booting. Oh my god, that worked. Let's just have a look if it reports its performance any faster. I mean, it shouldn't do because there's a theoretical limit on the drive, that I'm using here. It's getting around 1 meg per second on a 2000, I think. I'll report back if that comes back, but well, often it just freezes here. And actually thinking about it, this is not going to prove anything because it's running programmed I/O mode, polled I/O. It's not doing the DMA. Yeah, so unless you've got the DMA going on, you're not proving anything really in terms of can these really run at 14 megahertz with the DMA stuff happening. Because I think that's the issue. What I really need to do is put this board away, get a 2000 board out and test it that way. Anyway, I'll just test them this way just to see if they boot. It's not going to prove whether they work at 14. I can try and boot them with the 14 set, but I actually think even though that's set to 14, it's not hammering the SCSI anywhere near as much as it would do if it was be able to do a DMA insert this RAM. It's weird that it's when it's in a 4000 or a 3000 where you've got Zorro 3, this weird thing happens where it ignores that. I think other RAM takes priority and then the card goes, oh, but I can't DMA into that RAM. It's like, screw priorities. Stick with what you're supposed to, what you know. Because if you could DMA into the Zorro 2 there, well, we wouldn't have this issue. And something that I meant to point out in the previous video, but I'll point out here, when we had the VBB mod incorrectly in place, if you like, there was still a pull-up, wasn't there? There's a risk with that. What that means in practice is the VBB pin, whenever you see a VBB chip on an Amiga, it'll have a negative supply voltage created by a charge pump inside the chip, and if you were to stress that pin out for a period of time, which we could have done had I not realised that was the issue with in part 2, it could have damaged that charge pump. There are solutions to create your own charge pump. I've seen a few things recently where people have posted links to other sites and stuff where people have created a little PCB to create a -3 volts to provide that VBB pin with a negative supply. In the case where the voltage has dropped, instead of being -3 volts, it's down to -1 volt or less. So yeah, consider that an update to the VBB mod is something you need to be fully aware of. After absolute agony, I've got it working. You can see it's booting from SCSI, and we're using that RAM. I've also got some Zorro 3 RAM there from Live 2, and it's booted up. It's actually booted from SCSI. It's incredible. But I'm using a CPU card here. This is what I don't get. I've spent quite some time trying to work this out, and I'm not understanding it at all. So it's like when you've got an external CPU with an MMU. No, because the SCSI, the drive, it's got MMU libs on it, so I thought, well, I'll use the one that I did previously. This is what I was testing with before, and I got this to boot with an MMU error because there's no MMU on there. So anyway, I put the one in that's got an MMU, so we're just replicating what's on the board, the FPU and the CPU, and it works. Yeah, the jumpers are in the default positions here, like internal, the quadrature's on its 25 megahertz setting. I tried it on the 16, it doesn't make any difference in terms of it without a CPU card. So with a CPU card, it works. Without a CPU card, if you've got the FPU disabled down here, which, in fact that's enabled at the moment, it shouldn't technically be booting that way, because the onboard FPU might be enabled. I'm not sure. But the point is, you get a yellow screen if you disable the FPU without the CPU card. Is the FPU the problem? But that's a bit of a weird one, isn't it? How would that... It wouldn't make any sense. And I'm sure if I tested that FPU when I booted from IDE, I have. I remember doing it. So the FPU hasn't got a fault. The CPU seemingly hasn't got a fault because I can run everything on it apart from the SCSI. So we've got some borderline timing issue. And I was thinking, is it delay line? Well, the delay line's tapped the same way. So it's not the delay line. So explain that one. That's what I don't get. The only thing I can think is maybe one connection from the CPU somehow not joined to the board properly, and when you've got this CPU on there, well then it is. But then how does every other single thing you do, including testing all of the 256 meg on the Zorro 3 cards and all the 16 meg here, and doing every test under the sun, all work fine? I fail to see one address bit not getting somewhere unless you've got this providing that connection via some other route. I don't know, I'm absolutely confused with this one. But as you can see, it's booted. It's booted, these are all the drives. You've got two SCSI drives emulated by that Zulu SCSI card there. The performance is not great at the moment. It's okay, but, and this might be a clue, if I go into sysinfo, there's two icons at the top of each other there, and I do a speed test. This is something that I'm confused by. The overall performance here, 0.9. So it's 90% as fast as a 3000. How is it only 90%? Could be the way the card's set up, I don't know. We've got burst mode on, we've got instruction burst, all the cache is on. So that's a bit of a strange one. But I've seen this on this machine even without that CPU card in, when I was booting from IDE. So maybe that's a clue. And then it's saying Cowabunga chip speed 5.14, and if we go to the drives, we're getting currently about 1.5 meg per second. It may go faster than that with a change, putting it in synchronous mode, the SCSI that is, 1.5 meg log. So it's not rocketing along, but it's working, isn't it? I really need to test some of the other SCSI chips now to see if there's any difference there as well as playing around with the SCSI settings. The real-time clock chip on the 3000 holds, I think, some settings. There's some RAM in there, not very much. And using a few different utilities, you can enable synchronous mode, you can enable fast mode, you can do a few other settings there. You can change the timeout delay when it's booting, looking for SCSI drives. But it is working, and it seems pretty solid. I don't know, I'll test some games out on it. I don't know what I've got on this compact flash card now. Aha, we got a problem there. And there. What? Yeah, that bombed out completely, didn't it? Let's try again. Those look like DMA issues to me. There could be something wrong with that drive. Let's try something from one of the other drives. Yeah, maybe there's something wrong with the stuff on the other drive. It's not out of the realms of possibility. Although I'm not sure that's working actually. Yeah, I don't know. I don't know how to make sense of this. So we have got a DMA problem, I think. Oh, hang on. Maybe we haven't. Maybe it's just that drive. I'm just going to connect sound up because you know what? Right now we've got no sound. Yeah, we've got some music there, but it hasn't loaded properly, has it? In fact, it's just given us a blue screen. What? Let's try restarting it. There's some strange things going on here, and I don't understand any of it. It makes no sense to me. So that loaded. So if there was a DMA issue, well, it isn't presenting itself on the load of that image. And see, one thing I'm not sure about here is, should the quadrature clock be set to 25 megahertz or 16? It's on the 25 at the moment. Oh, I don't know, but brain hurts. You see, this might be because this RAM doesn't support, is it FP or static column, I can't remember. Static column mode, I think it is, but it might be fast. No, it's static column mode. I've ordered some more fast page sims, but anyway, those sims might not be compatible. Let's just try it with that to rule out DMA into this, because this could be the problem. We might have to get some zip RAM for this yet. Despite the fact this adapter exists, apparently the right type of sims with static column are very hard to find. Yeah, very slow when you're using Zorro free RAM. I noticed the the delays here. So let's try TimeGal again. If this works now, we don't get the graphical issues. No, it's still corrupted. So maybe it's just a DMA issue in general, or maybe there is something wrong with that drive. I don't know. It's graphics though, isn't it? It's like why would we be getting graphical issues here? One thought that does cross my mind about this, actually, now I think about it, is the display mode or something. That this card was cloned from a 4000, and I'm thinking about the display settings or something, like maybe, and it might have fast blit or some blit options or something enabled. Yeah, there's a bunch of things that I know from experience cause weird problems with other machines. You know, you've got to remember it's got an OCS Denise on it, this, so that could be just confusing things here. Yeah, you'll see what I mean. It's like, because this is cloned from a 4000, a compact flash card originally that came from Super Duper actually, which was amazing. Yeah, it's some of these things here, like, I don't know, stack attack, let's disable, already disabled. You can't get rid of that, can you? Fast blit disabled. Probably already disabled, is it? Oh, it is now disabled, right. Yeah, things like that can cause you copper disable. I don't know what that is. Already disabled anyway. Patch RAM disabled. Because you know what, I don't think you need to do that on a 3000. I don't know what that is. Tag on. Let's just try it like that. We've disabled a few things there. So I'll reboot it again. Oh my god, it's now not booting again. What is going on here? This makes no sense. Nope, still got the same problem there. See, what we do know is there's nothing fundamentally wrong with this Amiga, because if you boot from IDE, everything works from drives, and regardless of RAM. It throws it around on all the RAM without an issue, so we've not got some RAM specific DMA issue with Ramsey or whatever, or something where the SCSI can't, well, maybe the SCSI can't DMA properly, but everything else is working. I mean, now we've got SCSI working, what I'll probably do is swap over to the other SCSI card, actually. You know, another SCSI hard drive that's got a build that is more in line with OCS setups. Just in case there's something specific on this compact flash card where, you know, this drive, it's not compact flash, is it? Yeah, you see, that's bombing out. Yeah, let's swap the SCSI drive over. Yeah, boot the SCSI to SD. That's worked okay. Let's see if we can find TimeGal on here. No, we've got the same problem. So we do have some sort of issue. I don't know what. Isn't it mysterious? Oh, it's a bit better. It's a bit better. So is the quadrature clock something to do with this? Or do we have some weird thing with chip RAM where it's not, I don't know, I'm just going to press around there. I've got wrist strap on. what I was going to say is maybe when it's doing transfers to chip RAM, maybe we've got some like really weird minor timing glitch somewhere due to a fault. That means we get this stuff just when we're doing transfers to video related stuff. I don't know, it's weird. Yep, intermission. The black wire came out of the Amiga test kit adapter again. That one's getting soldered as well. And just pushing it back in here. Let's just see if we can get it to. Just trying to push it back in. Yeah, there we go. That's back in. If I just gently pull it. Yeah, it's not coming out, and it's at the right distance here. So let's give that a try. That's actually a lot better with a different SCSI chip. I am wondering if there was a power issue, you know. Let me just wiggle the power connections together. I am still seeing just the odd little corruption there. Yeah, I think it's the SCSI chip. So I've got a lot out here in terms of my trying to diagnose this issue with the Re-SDMAC and this board in general, because it may be a fault with the board. But we're in this situation, right, where it boots from an 030 card from the DM, you know, it does the DMA from the SCSI without an issue. But we get little lines in time gal. I think I may have shown you that. Like graphical artifacts, and it's a little bit unstable. And there's a relationship to the quadrature clock. If you set it to 25, it seems in some ways slightly more sulky than when it's set to 16. So that could point to the delay line, maybe there's something wrong with the delay line. What I really don't understand though is that you disconnect the external CPU card. It's just an 030, same as the one on there, with an MMU. We've got an FPU. When you disconnect that, it doesn't boot, it fails. It just, you know, the LED just flashes that one time and then that's it. The machine just black screens. You do have to disable the FPU on board in order to get this one working, because it's got an FPU. Now I ruled out the FPU because there was a weird thing with the FPU that if you removed this, and I think at some point it was getting a yellow screen when the FPU was enabled without, you know, just using the onboard CPU and FPU, and you disable the FPU and then you get black screen and it just freezes. So I was like, is there something wrong with the FPU here? What is it with the FPU? Why are we getting 1 minute a yellow screen and then a black screen, depending on how the jumper's set, when you're not using an external card? But I ruled out the FPU being an issue by removing the FPU from here, leaving the FPU on board enabled, plugging this card in without an FPU on it, yeah, if that makes sense, and then it worked. Yeah, just the same as it does when this card's on with its own FPU, if you see what I'm trying to say. So the FPU's been ruled out. I just don't understand. I don't understand how it can boot with an external card and not with the onboard 030. Now, I hear what you're saying. You're saying there's something wrong with the 030, Chris. Yeah, must be the 030. Well, if you remove the card and boot from the 030, just leave the SCSI out of here. Just do that, eject it. This flashes 5 times because it can't detect a drive. But in terms of the SCSI side of things, the interface is still there, it works, and you can boot from it boots, it's fine. You can boot from IDE, everything works, every benchmark, every test, everything you do, serial, parallel, external floppy drive, all of the chip RAM, all of the fast RAM, Zorro 3 cards, Zorro 2 cards, everything works normally. Like no glitches. You can run TimeGal from IDE. You don't get any little breakup of the images, you know, there's little lines all over the place. So it's mysterious, isn't it? Those lines, I think, is a DMA glitch. I actually think there's a DMA transfer going on when TimeGal's continuously streaming data from the SCSI, and we're getting a glitch. There's an edge not quite right. Now, a few people on the ReSDMAC forum there, you know, Discord, pointed out it's probably because the timing, Ramsey, and doing DMA transfers is very tight. So maybe it is your delay line. That would make sense for DMA, wouldn't it? Why the DMA is not working. But how does the DMA work better with this card? This is what I don't quite understand. The only thing I can think with that is that maybe there is, and we'll check on scope now. I'm going to get a second probe out. We'll probe the CPU clock and we'll probe the 90-degree clock and we'll overlay them and see, is it 90 degrees or is it slightly less or slightly more? What happens when we plug this in? does one of them shift slightly? Because it could be that the routing and components and things on this board here means that a slight inaccuracy in, say, let's say the 90-degree clock is, you know, instead of 90, it's 89 degrees out. It's, you know, it's not quite. It's 1 degree short. Let's say when this card's on there, the capacitance and the routing and the length of the connection here, you know, the extension on the clock signals and other signals potentially, maybe means we're getting an extra, you know, 1 degree on the 90 degree, and it might still not be quite right. It might be like, for argument's sake, it might be 88 degrees instead of 90, and we stick this on and it's 89, and it's borderline. It's enough to boot the SCSI, and it's enough to get some DMA glitches, loading time gal, but maybe it's not a 90 degree. That would at least give me some confidence that, yeah, it's going to be the time, you know, the delay line. And listen, time delay, the delay line. So I've ordered the little PCB which I think should work, that was created by Stefan R. I'll post a link to his GitHub, but that's going to be the next thing when that arrives. I've ordered it from OSH Park. I tried to order from PCBware, right? Get this. I added it in the basket from the shared projects and PCBware, and it said an under review. It was going to somebody in sales for them to review it, and I'm like, it's just a tiny little PCB. It's like, why can't I just order it? I've added it to the basket. Why can I now not check out? And then a minute or two later it said approved, and I just removed it by that point. And it's like, ask for the reason. I'm like, that's ridiculous. I'm ordering a PCB that costs £1 or something. You know, it was literally $3 or something for 5 of these things or something. And someone's having to review it. That is just absolutely ridiculous. So anyway, I went with OSH Park. PCBware, you know, they do a great job, but they've got some weird processes on their website. It could be far, far easier to just stick something in your basket and order it. No one should be able to, there should be no reason why someone would have to review a shared project that you've selected from their page and just added it to your basket. You should be able to add it to your basket and check out. It should be that simple. Not wait for someone to review it. Anyway, so where do we go from here? Well, I'm going to get the second probe. Let's scope those 2 clocks. I want to say the second probe. I mean, actually, you know, a second probe. How'd you get in here? Was this sealed and never opened, or what? Oh, there we go. It's one of those flappy ones. So it's the genuine Rigol probes that came with Allison's scope. I don't think I'm using a Rigol one at the moment. I'm using something else. But anyway, we've got the original Rigol probe there, so I'm going to stick that on. Now, handily, this one comes with the hood, and I've got a few of these somewhere, so you can do that, yeah, and just hook it on. So we'll use that for one of them. Need to make sure this set to the right attenuation. Yeah, the scope has 2 channels. It's got a separate trigger as well, anyway. So I need to find somewhere to connect this, and the grounds are always a pain on these things, aren't they? I wonder if I can find a ground somewhere, one of these jumpers maybe. Yeah, I think we'll go on that top side of that cap there. Yeah, it doesn't help with the clips on these. The crocodile clips are huge. That's not going to clip on there, is it? I don't think. No, it might do. It might just hold in place there. So I'm going to stick, this is going to be the next thing, hook this into the, if I can see what I'm doing, the centre of the jumper. Yeah, lifting you up here, you can see I've hooked it onto the centre part, the bridge of the jumper. So we've got one on that, that's the CPU clock, and this one is the board clock, which I think is the 90 degree one, but there's a quadrature clock. Is that not the 90 degree one? This is where I get confused. Anyway, we'll scope these 2 next to it, you know, these 2 to start with, and then we'll scope that one in conjunction with this one to see how its phase looks. Right, you can see them both overlaid here. The blue is channel 2, which is the CPU clock, I think. If we just change the scale here slightly, there is a bit of a difference here, you can see. And this is booting with the CPU card on at the moment. I'm going to take the CPU card off and see how these clocks here change, because ultimately that's going to provide a clue, isn't it? So I switch that off. But already I'm confused, because I would expect those to be more of a phase difference between them. Anyway, without that, you'll see this will just flash once. I get yellow screen at the moment, and you can show you that. Hang on. And you can see without a CPU card, where we get yellow screen, is it slightly more aligned to left? I think it is. And again, it looks weird, doesn't it? One of the clocks here is weird. The other one's pretty clocking, yeah? This one here's got a weird thing at the bottom and a weird thing at the top. And you can see, going like that, we're getting reflection. So there's something not quite right. So the blue one's left aligned there. We're getting a yellow screen. And as I say, that yellow screen has a dependence on the FPU. It's because there's no FPU at the moment, it's switched off. If I switch the FPU on, it's black screen. Why does it need an FPU? That makes no sense, does it? So what I'm going to do now is put the CPU card back on. So the blue was left aligned slightly, wasn't it? It was leading. The blue was slightly to the left side. So CPU card is on. Switch it back on. Now the blue is still left aligned, but you see, like, now it's booting. I think I'm just watching the LED. It flashed once, and it's flashing, it's booting. So it doesn't really seem to have made any difference there. To me, I can't see the difference on those clocks. I think the next thing is to compare to the quadrature clock. We'll stick with we'll measure against the yellow one, so I'll move the blue one. But you can see that flashing away, it's booting. This is the thing, it boots with the CPU card, and it's crazy, this. Right, so let's move this from... Oh, hang on, that's on the CPU clock. It's the quadrature clock one measure, so I'm going to move this over here to the quadrature clock, which is set to 25 at the moment. There we go, making sure my ground strap here doesn't short to the Re-SDMAC. It's all very precariously balanced here. Yeah, I've got it now on the quadrature clock, and making sure my ground strap here, I don't know if you can see it, doesn't short on the Re-SDMAC. So again, we're testing with the CPU card, so I switch it on. Well, that looks 90 degrees, doesn't it, I think. Again, it's a little bit bobby here, and the low point here. Look how weird it is. It's like squished to the left, which is not what I'd expect. You'd expect it to be a little bit more regularly formed. You know, it's pulled to the left, which is a bit strange. Anyway, that is booting. Yep, it's booted up. I'm going to switch it off. I think that was looking like 90 degrees. Let's pull this off. Try it without it. This is going to be the key. I don't know. It still looks like 90 degrees to me. But is it worse? Maybe it is. Maybe it's a bit more sharp and pointy here now. And maybe variable there a bit. I mean, if I overlay these, put these side by side, you know, this is without the CPU card at the moment. I'm going to take a picture on my phone, just for my own sanity, and then I'm going to put the card back in and just see what it looks like. But I'm having a very hard time understanding how the CPU card works, the onboard CPU doesn't. I've got the feeling I'm going to swap the delay line out for the new PCB by Stefan Reinauer, and it's going to be exactly the same. And that's going to leave me in an almost impossible situation of trying to understand why this doesn't work. I can see what's coming. I'm going to end up removing the CPU and the FPU and swapping them both. Maybe not. Maybe we'll just end up removing the CPU. You know what? I can't see any difference. Identical. I don't understand this. Yeah, so this is why I'm calling it now, and I'm going to say I think the delay line is not going to make any difference. But I do not like the shape of that blue signal. Is that the CPU clock? Let's just have a look. Yeah, that's the CPU clock. So you know what? Maybe it is all about the CPU clock. The point I'm trying to make here is this blue signal here, channel 2, is the CPU clock. So if you look at the yellow one, it's holding its shape a lot better. The CPU clock is glitching on the top and it's glitching on the bottom. So maybe where the CPU clock comes out the delay line is the issue. So we've not got a phase issue. What we do have is a problem with the shape of it, ever so slight, like maybe the delay line is creating that, because I'm pretty sure the CPU clock comes out of one of the taps on the delay line. I'm just thinking about this. One thing I could do is remove the jumper and actually join the two connections up with a ferrite. That might just make a little bit of a difference to the edges here, possibly. If that doesn't work, I could try and add a cap to that signal as well. Now I tried a 2 picofarad cap on this clock before, I think, and that didn't fix anything. And here's an interesting one for you. I've got a wire now, instead of the jumper, a wire, just to add some length actually. You know, that will add some capacitance. But a minute ago I just saw this change. It went down. What are you saying? Oh, look there. See that? See that? We're getting we're getting a logic level difference. That's bizarre. Channel 1, 1 volt. Channel 2, 1 volt. Oh, my head is hurting. Why would the level of that change? I'm trying to think what kind of faults inside the delay line would give you a higher voltage and then a lower voltage. I mean, it's not doing it now. Now it's not higher. It doesn't look right down here, though, certainly. This here, I can't really explain. And I would suggest if there was a problem with the delay line, that's going to be what it is. It's this deficiency here. We've got a corner missing. In other words, it's coming up. It's coming straight back up like there's a pull-up on it or something. I could try and pull it down. that might solve it. You know, it's like that bottom right edge. It's going like that. It's going up too quick. It's not long enough. Would that really make a difference though? Because well, maybe it would. You might get the cut off sooner. Having said that, I don't know. It is just this corner. Maybe that wouldn't make so much of a difference. But it is bobbing up and down there as well. It's not like it's just the shape of it. It's the fact there's some variation here. It could be affecting the logic low. Yeah. In the interest of just checking things here to make sure the probe is not the issue, I've swapped them around. So now the yellow is the CPU clock. I mean, you can see the same thing. So that shows me that it isn't about the channels on the scope. It's not about the probes. There is some distortion on the CPU clock at the bottom here. I tried feeding it through a 33 ohm. That doesn't seem to make a difference. I can't find any ferrites. I am wondering why it's lower than that. It could just be the way. Yeah, it's just the way this. Hang on. How's the yellow gone up? That's weird. It's like there is a difference in level, isn't there? Now an even bigger difference in level. This is the other thing I'm seeing here. Let's see if it shrinks back down again. Yeah, so feeding the CPU clock through a 33 ohm resistor, it's not made any difference. It's tidied up the signal. So what I mean is the bottom edge here now is not all quite as screwy as it was. So you know what, some attenuation there's helped with that. But it's still not booting. It would appear if there is a problem with the clocks, the CPU clock... I can just smell something weird here. I don't know what it is. Anyway, I'm going to take that off. I'm going to put its jumper back on. I'm going to try one of the other clocks actually. And this wants to be again on the internal position, the top one. So I'm going to go my resistor onto the centre pin. That's it. So that's now passing the motherboard clock through 33 ohm. Let's try that. Let's just see what happens in here. So we got that first flash, and then no boots. So that's not made a difference. I'll try the same thing with the quadrature clock. Those tests led me nowhere. I tested the quadrature clock the same way, and it doesn't make any difference. Some capacitance might have been better, but I've tried that already. That didn't make any difference. That was just like 2 picofarad. Maybe I should increase the capacitance, but anyway, we're using the external CPU card here and it is working. But it doesn't work with onboard. So I don't know. It's an absolute mystery, this. The only other thing is some of the signal on here, not a clock, is stronger than the onboard CPU can provide. Maybe there's a slightly weak address line, maybe. I don't know, I'm clutching at straws here. If there was a slightly weak address line, how would that make sense that you can boot from IDE and everything else on the machine runs perfectly? Why is it only Re-SDMAC? Well, you've got DNA stuff going on, so then I'm thinking, well, maybe the busmaster stuff. So somewhere there's some buffers on here, 646s I think, provided by, I think, Buster, that control the address lines for that. Maybe one of those is weak, but we'll put in an external CPU card, it's not going to strengthen it. So that would kind of rule out a board problem. This is where I'm just stuck. I'm completely stuck with this. It makes no sense. So I fitted the battery holder back onto this board and the CR2032. Granted, it's not very high charged. It's like 2.9 volts, I think we want to put on. It's an old one. Yeah, I downloaded the utility. If we go to the right volume here, it's on extra SCSI. Return key's working after I cleaned it with contact cleaner on this keyboard. Set bar. It's got hard membrane, that's the thing. Oh, you don't do set bar. Here you do set bar. Question mark. Yeah, what we can do is put synchronous mode equals I think it's yes. No, it's not. Is it Y? Yeah, there we go. So, SOS ID is 7. Synchronous transfer is initiated. Fast transfer is initiated. That's greater than 5 meg per second. SCSI 2 tag queuing. I don't know about that. It's disabled. And the timeout is set to 128 milliseconds. Logical units above 0 are not accessed. I don't think I need to worry about that. But the point is, because I've fitted the battery, the Ricoh real-time clock chip should hold that setting. And it should be reflected in benchmarks. I don't know about immediately. Let's just go into a benchmark here. So we were getting 1.5 meg per second on the SCSI previously. No, it's still 1.5 meg. So let's now reboot it. Synchronous mode is enabled. Let's remove the ripple. Now it should boot a bit faster. I'm going to set the time and date after that as well, just because, well, we've got a battery there now. Let's do that so it holds the settings properly. Drives, DH0, speed. There you go, 2.5 meg. So synchronous mode is working okay. I tested with time gal, it's exactly the same. So it's like not like putting it in synchronous mode and magically solves all the problems. If anything, going faster, you'd expect more problems. Yeah, so just taking an opportunity to clean up some of these solder points on this. There's not very many. There's, I don't know, a dozen or so far. Where are we now? Somewhere up here. Yeah, you can see here, I think this is one of the capacitor points. Can you see this trace here? There's a trace runs right next to it, and it kind of looks like it's bridged. It might not be. I can see what looks like copper there, like... I don't know, like is that supposed to go there? Yeah, you can see, I think that's separate. That trace has been pushed across though, so do you know what? I'm going to connectivity test that in a sec. And what looks like, that looks like a particle of solder there to me. This is what I saw a minute ago before I resoldered it. There. That looks like it's bridging. I don't think it should be. Keep losing where I am. Maybe it's an optical illusion, but anyway. I'm just going to continue cleaning up any solder points that don't look great. The one thing Cav said, and I can relate to this, he was like, it was quite hard to recap because the ground plane absorbs so much heat, and that is true. And you see, look at that, those kind of look joined, don't they? They really do. Looks like that trace has been pushed to the left. It's a bit UV solder mask or something there. And you can see the deflection in the trace there. Anyway, let's just connectivity test that, just to make sure it isn't joined, because it kind of looks... you wouldn't expect a fine trace like that to be joined to a cap point. It's not. It's very close though, isn't it? It's very close. Let's try and zoom in on it. Look how close that is. I need to move that out of the way. That is not good. That is not good at all. Let's see if we can do it with a probe here. I need to sort of try and come between them and slightly press to the right maybe. That may have done it, but I may have just broke the trace. Let's just try and measure it at this point here. Okay, if I measure from there to there, and there to there. Yeah, we don't need very much here. So he puts on lots. Anyway, that'll do. Just a little bit there. Yeah, just got my pliers like that there, and just set that over that. Just give that a minute or two. I'll just continue looking around though for anything like that around the points where things have been soldered, caps replaced, etc. Yeah, I am finding a number of weird solder points. I mean, look at this one here. You've almost got a dry solder joint. If you look at the three things there, I'm not sure if that's an EMI component or what. That looks baked. It's had a diode swapped around this area as well, so yeah, that needs something doing to it. I'll check that in a minute, but I think that's just something to do with one of the ports. Where are we here? We're here. Yeah, I think it's just serial or parallel. It could be external floppy drive actually, now I think about its location. So I'm going to reflow that like that. that definitely reflowed. But this one down here, it looks crusty as anything, doesn't it? That looks terrible. Absolutely terrible. That might be the diode that was swapped, I don't know. What you can do, if you struggle, increase the temperature you're in. Add some flux, yeah, we've got flux in this solder here. But heat it, hang on, heat it on one side, and obviously pay attention to where the solder is on the tip. And heat it on the other side. You know, alternate sides basically. And then you'll get a nice distribution of solder. Yeah, I think this had a repair before Kavanoz got, you know, swapped all the parts over to another board. Because, well, there was some suspicious things to do with diodes and stuff on it. Like, this is one of the areas of the board that looks like it's previously been fixed. So, I've not been critical of Kavanoz's work, is the point. But he did explain to me, he rushed through the recap and stuff on this, and like I say, struggled on the ground planes. It was before he had the, I think it was one of his early things he did, and he didn't have the right kit at the time, maybe. I don't know. Yeah, there we go. It's looking a lot better. It doesn't look it, but yeah, it is. It's a lot better. Yeah, I don't know whether you can see from there. I got one wire because I was checking the solder points, and I actually realised that there was one of them not joined to a connection on the board there. So I'll fix that as well. That would be for the scan doubler, I think. So the final thing I'm going to do here, other than just give it one final inspection in a minute, is just get a little bit of green UV solder mask. I'll show you that on the microscope, just on the 1 or 2 points around the fat Agnes there, from where I, you know, wrenched off the old pin strip stuff and fitted a socket. Yeah, and we can do this on the microscope. 1 or 2 of the solder points don't look great there, do they? It's just a consequence of the amount of rework that's been done to it. It's obviously, you know, been soldered a few times. Yeah, so I've got to try and find where they are. So this, hang on, where are we now? We're below it. Yeah, ignore the glossiness. So there's like a little bit there. There's a tiny little bit of copper. I'm using a cocktail stick. I don't know what's finer, but I'm trying to get it. That's it, right up there. So weeks later, I've got these things arrived. I've got a DS. I'm not sure this is the right chip actually. It's a DS1100. And then we've got the DS1000 PCB here from Stefan Reinauer. I'm sorry if I've mispronounced and mangled the name there. Stefan created this PCB to deal with problems with, well, these delay lines, you know, that you couldn't buy the dip ones really. Although a few people on my Discord did point me towards some replacement dip chips you can buy, so if this doesn't work, and there's no reason to think it wouldn't unless this is not the right, the two things, maybe I've not got the right chip here, or maybe this is not the right delay line for the 3000, it might be just the one for the A3640. This is what I'm not sure about. I'm not sure whether they use the same chip or not. It certainly looks like it's got the same number of pins. Anyway, we've got a couple of burrs to, you know, but not burrs, you know, the interposer things, you know, the things where it joins to the frame, the extended, you know, the larger PCB. Let's cut those off. I think I'll use the file on that. Yeah, OSH Park always leave these these bits on. I don't know why. No one else does. I can't get that off. I need to use a file on that. Anyway, I'm going to file those bits off there, get this chip on, and then we'll put some pins on it, you know, turn pins, that is. And I need to remove the old chip from the board and get a turn pin socket, and we'll have a go at changing for this delay line to see, does that make any difference to the issue with it? Booting from SCSI using an external card but not internal, I can't see how that would be an issue other than a tiny variance on one of these, the clock signals here, that means it works externally, it doesn't work internally because something's just marginal. Yeah, so I got these manufactured by OSH Park. So as I mentioned, this was created by Stefan Reinauer. I hope I've pronounced that right. He's an amazing guy. He's one of the authors of the A4091 remake, so there'll be a video on my channel coming up for that very soon. You know, he recreated the original Commodore A4091 with a new PCB, did some changes to it and stuff, enhanced it, and took the best of the final version, if you like, with some tweaks to make that, you know, a new all singing, all dancing SCSI card you can fit in a 3000 or 4000. He's also done a recent compact version of that, which replaces all of the logic from the GALs into a single CPLD and modern chip, which is just incredible. It really is. But he's also taken up the redesign of Marine, that's the Amber project I created, and come up with a PLCC plug on a multi-layer board, and it looks incredible. So hopefully there might be a PLCC version of Marine where you can just literally, you know, either assemble or purchase one of those and just plug it straight into your socket. Obviously it needs testing and stuff yet, I'm not sure. I think Kavanoz may have ordered the initial batch of those, which is incredible. So I might get a chance to have a look at that in a future video. But yeah, hats off to Stefan. He's an incredibly talented guy. There'll be links down below to, you know, the place that I got this PCB layout from, and perhaps some of his other projects. Just inspected that off camera. That second one down there is a problem. It isn't kind of flowed properly onto the pad. It might be a ground, I don't know. Let's just try and some extra flux. There we go. Just give each of those a reflow. Yeah, that's got it. So I just need to just clean that up and get the pins on. Right, got to get the delay line off now. Yeah, so I found it really painful to desolder things on these boards. It's probably my awful solder station. I tried that and the solder pump and the Heiko. The Heiko was increased from 405 to 465 for a couple of the points up here, down there and down here. It's like, you know, ground VCC rails that are bigger on the board. Yeah, it's not coming off. Oh, it is. Oh, it is coming off, I think. Hey, it's off. No damage. So, clean up with the cotton bud here. Get a turn pin socket on. Get some legs onto that PCB we've just created. And yeah, we can get the new delay line on. Right, I don't have any turn pin sockets, so I've cut two strips. They're not exactly the same type of gold colour, are they? It doesn't really matter too much. So I need to get that nice and flat and level now, so I'm going to solder one point at a time until I'm convinced it's completely level. Where's the pins here? That's the top row. Right, that's that soldered on. It looks a horrible fluxy mess, so let's clean that up now. Yeah, I don't think this is going to make any difference to our issue. I really don't. I think this is all just completely, well, par for the course to check it. Because whilst we've scoped it, and I've had experimented with caps and resistors to see if it can influence the signal there, we did see it go, all of the logic levels on it go weird, didn't it? It's like 1 minute it changed. There's nothing else that could do that, I don't think, other than this delay line. Dry brush some polish. That looks alright. That looks okay, I think. Doesn't look very straight there. Yeah, it is. And obviously we've got the edge missing off that. You're not going to see it though, because it's just going to be in the socket, sort of an angle where you can't see the edge of it anyway. Anyway, let's now get the 3000 back on the bench and give that a try. I'll just clean that up later. Right, so that slid straight in without an issue. Got the power connected, got video and audio, main switch isolated here, you know, the on-off switch. Everything is there apart from the bridge. Let's get the bridge back in, because otherwise we'll get a yellow screen anyway. Go and quick start. I think we diagram it. I think it's fine without it, actually. I suspect it causes an auto-config type thing. Well, I know it does. It creates an auto-config type problem when you don't have this connected, because you've got a couple of buffer chips and some resistor arrays and things on there. It's the buffer chips, I think, that's the issue. You get an auto-config chain issue. Right, let's power that on. Hang on, I'm just going to look over there just to make sure it doesn't go up in fumes. Switch it off. I'm just going to touch that. It's not hot. Yeah, let's just see if we get a sticker disk in screen. It's booting. Well, I think it's booting because I saw grey background and it disappeared. So I don't know, maybe it's not. Oh, it is booting. There we go. So yeah, the delay line works. Fantastic. Fantastic. Right, let's try it with SCSI. Does it actually boot with SCSI? Because this is where I'm calling it now. I'm going to say I don't think it will. I think it's going to have the same problem. Right, so our SCSI is connected here. Let's just see what happens now. Yeah, that's normal. And that isn't. So we've still got the same problem. So that delay line change was completely pointless. A complete waste of time, which is what I thought was going to happen, to be honest. I've been sat here for the last 2 weeks waiting for that PCB to arrive, thinking, don't know why I'm waiting for that to arrive, that's not going to solve it. And there you go, I'm right. So I don't know where to go from here. I actually think the Re-SDMAC has a glitch, something that's been overlooked. That means there's something marginal, a marginal signal. And on one board it works, on another board it doesn't. That's what I think. Because I think Liv 2's got the same type of problem. Liv 2 came to test the Re-SDMAC on his board, and I think he said he got so many power flashes. I haven't got an LED, so I can't tell whether the power light's flashing, but I'll bet you anything that's what's going on. I'll bet you anything it's given a flash code. Yeah, so I tested it with this original delay line back in, it works fine, so it's no worse for wear, but that's made no difference. Yeah, booting from IDE, that works alright. You can hear Pinball Dreams fine. And it's like I say, the Zorro cards, the Zorro 3 ones, the Zorro 3 RAM, everything works, but it doesn't with a SCSI. You know, if you look at the schematics for the 3000, what's actually involved in the SCSI, well, there's very little. The connectivity between the SCSI chip and the Re-SDMAC, you know, the DMAC, that is Super DMAC, and just the control signals that go from various places. Well, we know those are alright, because it wouldn't boot from the 3640, would it? You know, not 3640, A3630. If there was some general problem, there isn't. So yeah, I'm very pleased that we've got to this point. I'm pleased that SCSI works. I think if we tested it with another CPU card like a BFG maybe, that might work, but I think at the moment there are some issues getting CPU cards working, So the video was running on in length a bit. We fixed everything in the next video. We made some good progress in this, trying to understand the nature of the problem with the SCSI, but yeah, everything becomes completely resolved in the next video. A huge thanks to Kavanoz for sending this board. I can't thank you enough, Kavanoz. Goes without saying, massive thanks to Mike T for sending me the Re-SDMAC. But also, I'd like to thank Mike and Andy T, yeah, they're not related to each other, different surnames, for the offers there on helping trying to understand the nature of this problem. Both guys offered to send me an SDMAC, actually, an official one, you know, not a Re-SDMAC, just to rule out, was the problem with the Re-SDMAC? Well, it's not the problem with that at all. And Mike T even offered to come around, you know, he lives reasonably close to me. Yeah, I had to turn his offer down, but it was very, very, very much appreciated. Thank you for that, Mike. And it was very, very soon after that I worked out the issue. And another small thanks to Jamie Morgan for sending me the Agnes that this board's up and running with. And the other thing, before I forget, was this little cool delay line replacement from Stefan Reinauer. So, absolutely brilliant work, Stefan. Thanks ever so much for creating that. Anyway, I do hope you found that video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Please like, share, hype, whatever the video. It just keeps the channel going, and you know, the more likes and things and comments and things we get on these videos, the more chances of the algorithm actually making a difference. My channel's just gone down, 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 but you know, I just keep going for the moment. Whilst we've got support on Patreon and Ko-fi, then I have a reason to keep going. And obviously amazing donations like this keep me going, really. So I can't thank you all enough for your support. I'll catch you in the next video.